In this video, we're going to talk about factoring trinomials with a leading coefficient of 1. So let's multiply the binomials here. So when we do the FOIL method, we get x squared plus 2x plus 10x plus 20. And then combine like terms here, we get x squared plus 12x plus 20. All right, so what is the last operation used to get the 20? Well, I took 10 times 2, so that's multiplication. What's the last operation used to get 12x? Well, if we go back a step, we did 2x plus 10x, so we did addition. So if we wanted to go from x squared plus 12x plus 20 to the factored form x plus 10 times x plus 2, what do? We took factors of 20, 10 times 2, whose sum is 12. 10 plus 2 is equal to 12. So in general, to factor trinomials of the form x squared plus bx plus c, we want to determine factors of the constant, which is c, whose sum is b. Okay, so let's factor completely. So first thing we want to do, is there a greatest common factor that I can take out of all of these terms other than 1? The answer to that is no. Leading coefficient is 1. So now we want to find factors of 12 whose sum is positive 13. Well, there's two ways to multiply numbers to get a positive. Either a positive times a positive or a negative times a negative. Because it's positive 13x in the middle, we know it's going to be two positive factors. So I'm going to create my factor sum table. So factors of 12 whose sum is 13. Well, we got 1 times 12. We got 2 times 6, and we've got 3 times 4. 1 plus 12, that's 13. 2 plus 6, that's 8. And 3 plus 4 is 7. So the factors we want here are 1 and 12 because 1 plus 12 is 13. So how do I break down x squared? That is x times x. So we want 1 and 12. Now, if we multiply these, we should get back to the original trinomial. And in this case, we do. So we have factored this completely. Now, note, I could have written x plus 12 first times x plus 1 and would have gotten the same exact answer because multiplication is commutative. Okay, let's go to the next example then. So, first question, is there a greatest common factor I can take out of all three of these terms other than 1? Answer to that question is no. The leading coefficient is a 1, so I want to find factors of 36 whose sum is a negative 13. So, we know it's going to end up being a negative times a negative because a negative times a negative is a positive, but when I add two negative numbers up, I get a negative. So we'll do our factor sum table. So factors of 36, whose sum is negative 13. So let's write some of these factors out. So negative 1 plus a negative 36 is negative 37. Adding these two factors, that gives me negative 20. Adding these two is negative 15. So we don't need to go any further. We know these are going to be the two factors that we care about. So how do I break down r squared? That's r times r. One of the factors should be 4, and the other one should be 9. So again, we can multiply to check our answer. And indeed, we get our original trinomial. Okay, let's go to the next example. So again, first question, is there a greatest common factor I can take out of all three of these terms other than 1? Well, the answer to that question is no. So now we want to find factors of negative 12 whose sum is negative 4. Well, in order to get a negative number when you multiply, one number has to be positive and the other one is negative. So again, we want to find factors of negative 12 whose sum is negative 4. Now, you want the bigger number to be negative because we know the sum is going to be negative. So again, add. This gives us a negative 4, which is what I want. Those are the two factors. So, how do you break down x squared? That's x times x. Now, notice the third term has a y squared. So not only do I need to put the number factors, I also need to put a y, because y times y is y squared. So the positive factor, that's the 2. The negative is 6. Let's check to make sure that this works. And it does indeed work here. Okay, let's go to the next example. So first question, is there a greatest common factor I can take out of all three of these terms other than 1? And the answer here is yes. I can take out a 3, I can take out a factor of a, and a factor of b. Because the first term is negative, I'm also going to factor out a negative. So let's take out a negative 3ab. Divide it out. Okay, so now go inside the parentheses. We're back to a trinomial where the leading coefficient is a 1. So now I want to find factors of 42 whose sum is negative 13. Both factors must be negative, so in this case, I'm just going to write out the factors that are going to work. So in this case, that's negative 6 and negative 7, and they add up to be negative 13. So bring the greatest common factor down. Both are going to be negative. I break down a squared as a times a, and then 6 and 7. So I will not multiply this out to check your answer. That's something that you can do on your own. Okay, let's do the next example. So again, first question, is there a greatest common factor I can take out of all of the terms other than 1? In this case, you can. That's a 2. So divide out or factor out a 2 from each term. So now, look inside the parentheses. The leading coefficient is a 1. That's good. So now I want to find factors of negative 4, F for factors, S for sum, of negative 2. Well, one of the factors has to be positive. The other one has to be negative. The bigger one should be negative because the sum is negative. So not a lot of options here. But notice here, when I do them, none of them end up being negative 2. So what does that tell me? That means I cannot factor it any further. So in this particular problem, the only thing I can do is to take out the greatest common factor, and I am done. Okay, one other example I want to take a look at. So again, first question. Is there a greatest common factor I can take out of all the terms other than 1? And that's no. So again, 3 terms. So I want to find factors of 12 whose sum is 5. Both factors have to be positive. Okay, so let's add. Again, none of these factors add up to be 5. This is what is called a prime polynomial. So if this circumstance ever comes up, you would write prime, and that means it is not factorable.